Good evening, everyone. All right. So without further ado, let's get started with next topic. Students, the back and forth process. There are certain doubts students are having. We'll come back to those doubts. But right now, let's continue with topic. All right. Let's see some basics of transformational functions. All right. Let's say about a one-dimensional line. To spot a point on this line, I need an origin and distance from origin. So I can spot a point on this line with a distance from a certain point, fixed point called origin. In one-dimensional line, I need one number. So to spot a point on a one-dimensional line, I need one number. If I've got two-dimensional plane, then I need two numbers. What kind of numbers? Let this be alpha. Let this be x-axis. Let this be y-axis. Let this be origin. I need two numbers, distance from origin as x naught and distance parallel to y as y naught, and the number is represented as x naught comma y naught. All right. So for a one-dimensional line, I need one number. For a two-dimensional plane, I need two numbers to spot a point. To precisely spot a point, to pick a point, I need two numbers. And this system is called coordinate system. If this alpha is not pi by 2, this is called an oblique coordinate system. Oblique coordinate system. If this alpha becomes pi by 2, if this is pi by 2, that means these are perpendicular to each other. That's called a rectangular coordinate system, where my point should be x naught distance from origin and y naught parallel to y-axis this way. So I need one number for one-dimensional line, two numbers from two-dimensional plane. So it makes sense to say that I need three numbers for three-dimensional space. 3D will deal with 3D after differentiation. When we do integration, we'll deal with 3D space. Right now, let's confine ourselves to 2D. All right. Now look at the students. A point x naught comma y naught. If I have to spot on this plane on rectangular coordinate system, when this is perpendicular, that's called rectangular coordinate system. So the previous ones are called oblique coordinates. These are called rectangular coordinates. It is very rare that we use oblique coordinates. There are cases where we use one or two cases where we use oblique coordinates to solve problems, but mostly, in fact, almost every time we'll be using rectangular coordinate system to spot a point on the plane. Now look at this. If I draw a line parallel to y-axis at a distance of x naught from origin, this way, the condition which this line satisfies is that its x coordinate is x naught, no matter what the y coordinate is. So the equation of this line I can write as x is equal to x naught, or its coordinate is constant. it's this line's coordinate is constant. Which coordinate? X coordinate is constant. Similarly, if I draw a line parallel to x-axis this way at a distance of y naught, this line satisfies the condition that its y coordinate is constant. So this is called a constant coordinate line. This is called a constant coordinate line. So in one-dimensional space, I need one point, only one number to spot a point. In two-dimensional space, I need two numbers to spot a point. It could be this way or this way. So these two numbers are called coordinates of the point. So the two numbers required to precisely spot a point or precisely pick a point are called coordinates of the point. All right. Now, so let's see how we get a point. In general, how we get a point. Now, this definition is very important for you to understand even in 3D cases. The definition goes like this. The intersection of constant coordinate lines gives a point. All right. So intersection of constant coordinate lines. So this is a constant coordinate line. 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 So intersection of two constant coordinate lines gives me a point. If in space, constant coordinate surfaces. All right, you please make a note of this sentence. Intersection of constant coordinate lines gives a point. All right, this is very important point if you want to understand polar coordinates, spherical polar coordinates, and cylindrical polar coordinates. All right. Presuming you have understood this, students, are you able to follow whatever I've said till now? If yes, please type yes in the chat box so that I can move forward. Okay. Good, good. Excellent. Okay. Right. So, Bhavna, what's your doubt precisely? పాయింట్ స్పాట్ చేయడానికి ప్లేన్ లో నాకు టూ నంబర్స్ కావాలి. ఒక నంబర్ ఏమో ఆరిజిన్ నుంచి అలాంగ్ ఎక్స్ యాక్సిస్, ఒక నంబర్ ఏమో ఆరిజిన్ నుంచి అలాంగ్ వై యాక్సిస్. ఆ టూ నంబర్ కలిపేసి నేను x0, y0 అని పాయింట్ కి పేరిస్తాను. కానీ ఆ డిస్టెన్స్ దగ్గర ఒక లైన్ డ్రా చేస్తే x is equal to x0 అని, that is a constant coordinate line. Why is it called a constant coordinate line? Its x coordinate is constant on the whole of the line. Similarly, its y coordinate is constant along whole of this horizontal line. So these two are constant coordinate lines. ఈ రెండు ఇంటర్సెక్ట్ అయినప్పుడు నాకు ఒక పాయింట్ వస్తుంది. ఎప్పుడైనా ప్లేన్ లో టూ కాన్స్టెంట్ కోఆర్డినేట్ లైన్స్ ఇంటర్సెక్ట్ అయినప్పుడు పాయింట్ వస్తుంది. స్పేస్ లో త్రీ కాన్స్టెంట్ కోఆర్డినేట్ సర్ఫేసెస్ ఉంటాయి. సో ప్లేన్ లో వచ్చినప్పుడు నాకు టూ నంబర్స్ కావాలి. ఒక లైన్ ఉన్నప్పుడు నాకు ఓన్లీ వన్ నంబర్ కావాలి. సో వన్ డిమెన్షనల్ స్పేస్ రిక్వైర్స్ వన్ పాయింట్, టూ డిమెన్షనల్ స్పేస్ రిక్వైర్స్ టూ పాయింట్స్, two-dimensional space requires 2 points, x0 and y0. Three-dimensional space requires x0, y0, z0. But in space, you'll have surfaces instead of lines. Right now, you just think of lines. Surfaces, when we deal with surfaces, I'll teach you surfaces. I'll show you some figures on the PPT. You'll be better able to understand that. All right, some 3D figures. We cannot draw 3D figures on the board properly. So 3D figures, I'll show you on the PPT. So you'll be able to better understand surfaces that time. But right now, focus on that constant coordinate lines ante enti, line for which its coordinate is constant. One of the coordinates is constant. X coordinate is constant for this line. Line for which one of the coordinate, which is y coordinate is constant for this line. Intersection of these two lines is my coordinate point, x0, y0. నేను ఇలా కూడా చెప్పొచ్చు, x0 distance from origin, y0 distance from origin, అలా కూడా చెప్పొచ్చు. కానీ పోలార్ కోఆర్డినేట్స్ లో వచ్చినప్పుడు కొంచెం కష్టం అవుతుంది. ఆల్ రైట్. Is it clear now? All right, good, good. Most welcome. Good. All right. So let me just introduce you to what is polar coordinate system. Then we'll come back to Cartesian coordinate system. Just to emphasize this line, I will introduce you to polar coordinate system, but we are not going to work on polar coordinate system today, which is very important for physics. We'll not work on it today. We'll work on functions today. I need 2 points, I said. Right? ఒక ఆరిజిన్ ఫస్ట్ ఆఫ్ ఆల్ ఆరిజిన్ కావాలి నాకు. ఆరిజిన్ ఉంది. ఇప్పుడు నేనేం చేస్తాను, ఇది ఒక లైన్ తీసుకున్నా, నాకు ఈ పాయింట్ ని స్పాట్ చేయాలి. ఈ పాయింట్ ని ఎలా స్పాట్ చేస్తాను? ఎక్స్ అండ్ వై యాక్సిస్ ఉంటే ఇలా చేశాను, ఎక్స్ నాట్ వై నాట్ అని చేశాను. ఎక్స్ నాట్ వై నాట్, ఎక్స్ నాట్ కాన్స్టెంట్ కోఆర్డినేట్ లైన్, వై నాట్ కాన్స్టెంట్ కోఆర్డినేట్ లైన్ తో ఇంటర్సెక్షన్ వచ్చింది. బట్ దెన్ నౌ ఐ డోంట్ వాంట్ యూస్ కార్టెసియన్ కోఆర్డినేట్ సిస్టమ్. ఐ యూస్ పోలార్ కోఆర్డినేట్ సిస్టమ్ విచ్ సేస్ ఒక లైన్ ఉంది కాల్డ్ ఇనిషియల్ లైన్. దిస్ మై ఆరిజిన్. ఇక్కడ నుంచి నేను ఒక యాంగిల్ రొటేట్ చేస్తా, థీటా. రొటేట్ చేశాక అలాంగ్ దిస్ లైన్ ఒక డిస్టెన్స్ వెళ్తా, డిస్టెన్స్ ఆఫ్ ఆర్ నాట్ అనుకోండి. ఈ పాయింట్ నాకు వస్తుంది. సో దిస్ పాయింట్ కెన్ బి స్పాటెడ్ with these two numbers. ఒక యాంగిల్, ఒక నంబర్. I can say this is 30 degrees and this is some 2 meters. Right? Or I can say this is 45 degrees and this is, let's say, root 2. అంటే 45 degrees నేను రొటేట్ చేశాను నా లైన్ ని. ఈ లైన్ లో నేను ఒక రూట్ 2 డిస్టెన్స్ వెళ్ళాను. ఈ పాయింట్ వచ్చింది నాకు ఈ పాయింట్ కావాలి. ఎలా చేస్తాను? ఐ రొటేట్ at an angle of certain angle theta or alpha. I'll go a distance of some distance x along this line or r along this line. I'll get this point. All right, so I need two numbers. Always remember, for a plane you need two specific numbers to spot a point. In Cartesian coordinates is x comma y. In polar coordinates it's r comma theta or r comma alpha. Now that could be root 2 comma 45. ఎలా చేశాను? ఇప్పుడు 45 degrees రొటేట్ చేశాను, ఆ లైన్ మీద రూట్ 2 వెళ్ళాను, నాకు రూట్ 2 వచ్చింది. ఆ లైన్ మీద 2 డిస్టెన్స్ వెళ్తే 1 డిస్టెన్స్ వెళ్తే నాకు ఇక్కడ వరకు వస్తుంది, 1 ఇక్కడ వరకు వస్తుంది. లెట్స్ సే ఇఫ్ ఐ గో టిల్ హాఫ్ ఇక్కడ వరకు వస్తుంది. సో దిస్ ఇస్ హాఫ్ కామా 45, దట్ ఈస్ 1 కామా 45 and that is root 2 comma 45. So I need two numbers. One number is distance, the other number is angle, which is also a distance along the arc, but it's angle. Now, but what did I say? Intersection of constant coordinate lines gives a point. But where is the constant coordinate line here? Let's see that. ఇది ఇనిషియల్ లైన్, ఇది ఆరిజిన్. నేను థీటా ఈజ్ ఈక్వల్ టు 45 degrees ఆర్ 45 degrees తీసుకుందాం. 45 degrees కాన్స్టెంట్ ఉండాలంటే ఏ పాయింట్స్ వస్తాయి నాకు? ఆల్ దీస్ పాయింట్స్ ఆర్ ఆన్ 45 till infinity. All these points make an angle of 45 with the initial line. So this is a constant coordinate line. What is constant here? That angle is constant here. The polar angle is constant. Now, what is the other coordinate? R, or distance from the origin. If distance is constant from origin, we know from circles that if distance is constant from a point, what I get is a circle. if distance is constant from a point, the locus which I get, the curve which is traced by this point is a circle. You all agree with this? All right, good. So this is a constant coordinate line, which is a semi infinite line. ఇక్కడ నుంచి స్టార్ట్ అవుతుంది, ఇన్ఫినిట్ వరకు వెళ్తుంది. జీరో నుంచి స్టార్ట్, ఆరిజిన్ నుంచి స్టార్ట్ అయ్యి ఇన్ఫినిట్ వరకు వెళ్తుంది. This is a constant angle line. This is constant distance line. ఇక్కడ distance is constant from the origin. If I combine these two, intersection of these two gives me the point. So this is my point. రూట్ 2,45. ఇంతకు ముందు కూడా అదే చేశాను కదా. ఇది ఇనిషియల్ లైన్ అనుకుంటే 45 డిగ్రీస్ ఇలా వెళ్ళి 45 డిగ్రీస్ రొటేట్ చేసి ఆ లైన్ మీద నేను రూట్ 2 డిస్టెన్స్ వెళ్ళాను. అప్పుడు నాకు పాయింట్ వచ్చింది. కోఆర్డినేట్ యాక్సిస్ లో ఏం చేశాము? x0 డిస్టెన్స్ ఎలాంగ్ x యాక్సిస్, y0 డిస్టెన్స్ ఎలాంగ్ y యాక్సిస్. ఈ టూ నంబర్స్ కలిపి నాకు ఒక పాయింట్ వచ్చింది. కానీ బెటర్ వే ఆఫ్ మెన్షనింగ్ ఇట్ వాజ్ వాట్? ఈ కాన్స్టెంట్ కోఆర్డినేట్ లైన్ x is equal to x0, కాన్స్టెంట్ కోఆర్డినేట్ లైన్ y is equal to y0. ఈ రెండు కంబైన్ చేస్తే నాకు పాయింట్ వచ్చింది. See, I'll make you do some practice, then you will be able to understand better. All right. We are just understanding the theory, consolidating the concepts. We'll do some problems. All right. We are making an assignment, so don't worry about it. If at all you are not able to catch immediately, that's okay. These things are new to you. All right. These ideas are new to you. All right. These ideas, coordinate geometry మీకు ఉండే, but those ideas are different from these ideas. Little different. But ultimately the concepts are same, but ideas are little different. All right. So the constant coordinate lines, which is one line is this, the other line is this. In geometry, in coordinate geometry, line ante straight line e kaadu. దీన్ని straight line అంటారు, దీన్ని కూడా line ఏ అంటారు. Even this is a line, a curved line. This is also a line, a circular line. This is a straight line. All right. So constant coordinate line. So one constant coordinate is theta is equal to 45, which is constant along this line. Intersection of this line with the circular line which I had. Constant distance line. R is equal to root 2. Intersection of these two gave me root 2, 45. All right. So this sentence is very important for us to understand. Do crack problems in integration also. In physics. Intersection of constant coordinate lines gives a point. ఒక constant coordinate line theta is equal to 45, ఒక constant coordinate line r is equal to root 2. ఈ రెండు ఇంటర్సెక్షన్ ఏమో నాకు పాయింట్ వచ్చింది root 2, 45. All right. Is this clear, students? Okay, good. Yeah, please, everyone be interactive. I got responses almost from everybody, but I'm unable to read the names. I appreciate that. All right. Now, let's understand one thing. How do we plot a line? Y is equal to kx plus c or mx plus c. M place of m రాస్తాను సరే. Okay. How do you plot a line? Y is equal to mx plus c. So what do we do in Cartesian coordinates, in rectangular coordinates? This is x-axis, y-axis. This is 90 degrees. What I do at x is equal to 0, I get a point at x is equal to 0. This line passes through this point. That's for sure. Right? That's the y-intercept. When x is equal to 0, this becomes 0. So y is equal to c at that point. At x is equal to 0. Now, the slope of this line is m. So what is the angle it makes with the horizontal x-axis? It is m is equal to tan theta So theta is equal to tan inverse m. So if I have a line y is equal to x plus 1, when x is equal to 0, it is 1, 1. Value of m is 1 here. So tan inverse 1 is 45 degrees or pi by 4 radians. So it makes an angle of pi by 4 with the x-axis. So that's the straight line I get. This is one way of plotting a straight line. Sketching a straight line. We are not plotting it. There's a difference between plotting and sketching. Plotting లో ఏం చేస్తారంటే you will take few points x1, x2, x3, x4 తీసుకొని y1, y2, y3, y4 తీసుకొని ఆ పాయింట్స్ డ్రా చేసి స్పాట్ చేసి గ్రాఫ్ లో దాన్ని కనెక్ట్ చేస్తారు. దాన్ని ప్లాటింగ్ అంటారు. బట్ వీఆర్ స్కెచింగ్. స్కెచింగ్ అంటే వీఆర్ సీయింగ్ ద క్యారెక్టరిస్టిక్స్ ఆఫ్ ద లైన్ అండ్ వీఆర్ డ్రాయింగ్ ద లైన్. క్యారెక్టరిస్టిక్స్ ఆఫ్ ద లైన్ ఏమున్నాయి? y ఇంటర్సెప్ట్ ఉంది, ఇంకా స్లోప్ ఉంది. Slope and y intercept together will give me complete information about the line. All right. So let us plot two straight lines like this. Then we'll go for the faster method. Mx is cancelled. It's not cancelled. I said x is equal to 0. So when x is equal to 0, this is 0. That's why I just crossed it out. All right. So when x is equal to 0, mx is 0. So what remains is y is equal to c, intercept. All right. I have just shown it by striking it off that it is 0 at x is equal to 0. All right. Have you noted this point in the footnote or wherever comfortable for you? Intersection of constant coordinate lines gives a point. It would be better in a footnote actually. All right. Now look at this. Let's plot a is equal to root 3x. So how do we plot this? There is no intercept, plus 0. There is no intercept at all. So it passes through origin. This line definitely passes through origin. So there are many lines like this. 1, 2, 3, 4, infinite number of lines passing through origin. But this has a slope of root 3. So the angle it makes with the x-axis all right. See, we are doing coordinate geometry and then functions. All right. We're doing coordinate geometry, a bit of coordinate geometry, and how to plot functions, how to plot straight lines and some curves, so that I can move on to the next topic of differentiation. We are doing basic math for physics. All right. We are still into basic math itself. We need to enter into physics. All right. Y is equal to root 3x. So m is equal to root 3. So theta is equal to tan inverse of root 3, which is, what is tan inverse root 3? Yes, good. Yes, it's 60 or pi by 3. All right. Or it could be written as 60 degrees also. Both are okay. Both are okay. Both, you'll see both the things in problems. Okay, it would be 60 degrees or pi by 3 radians. Okay, for convenience, I'll just write it as 60 degrees. Now, this is a straight line which we have got with y is equal to root 3x. We have sketched it. Now, let us say I've got another line y is equal to x by root 3. What would this line be? This would also pass through origin because there is no intercept. Y intercept is 0. And slope is 1 by root 3. So tan inverse of 1 by root 3, which is equal to 30 degrees. So this is straight line 1, straight line 2, straight line 1, straight line 2. All right. Now let us plot y is equal to x. Y is equal to x. What angle would this line make with the x-axis? And would this pass through origin? Or will it have an intercept, y-intercept? Excellent. Bhavisi, excellent. Good. Yeah. So Bhavisi has already given me the answer. All right. So slope is 1. So theta, angle it makes with x-axis is tan inverse of 1, which is 45 degrees. So line number 3, it makes an angle of 45 degrees. All right. So this is how we sketch a straight line without an intercept. If we have an intercept, what we do? Say I have to plot root 3x plus 1. One is y-intercept is 1, and angle it makes with the x-axis is 60 degrees. So this is my straight line 1. Root 3x minus 1 would be passing through minus 1 and making an angle of 60 degrees with the x-axis. So these two lines are supposed to be parallel. Are they looking parallel? Yes, they're almost parallel. All right, I could fortunately draw them as parallel. Fine, that's good. All right, now, so that's how we plot a straight line, right? All right, now let's see some transformations. Then let's come back to plotting a straight line in a quicker way. All right, can you all plot this one? Root 3 times x plus 1 y is equal to root 3 times x plus 1. Think of it. How do we plot it? So expand it. Root 3 times of x plus root 3. So now y-intercept is root 3. Y-intercept is root 3 and slope is root 3. Y is equal to mx plus c. So it will pass through root 3 and make an angle of 60 degrees with x-axis. All right, that's how we plot straight lines. Straight lines are fine because we have got a very simple information in the straight lines. One is slope, one is intercept. But there are some curves which have got a lot of information in the curve. There could be some curvature, there could be some upward cup or downward cup, concave upward, concave. There are certain other properties of the curves which cannot be deduced that easily as we have done slope and intercept. Slope was very easy. Getting the angle is very easy. Tan inverse m is angle. C is nothing but I just plot that C on the y-axis, mark that C on the y-axis, and angle on the x-axis. I draw the line. That's it. That's very simple. But there are curves which are not that simple. For that, we use transformations. Yes, Bhavna, you're right. You're supposed to plot C value on the y-axis. Why? Because when you have y is equal to mx plus c, when x is equal to 0, 0 plus c. So y is equal to c when x is equal to 0. When x is 0, that is on y-axis, my value of the function is, or value of the y value is c. That's why I mark that intercept on c. That's why it's called y-intercept. All right, that's why it's called y-intercept. Just a sec. All right. Now let us say I've got a function, some random curve like this. All right. This equation we'll talk about it later. But right now it is a curve which is f of x. All right. This is a curve of some equation. All right. Graph of some equation which is f of x. Y is equal to f of x. Now, if I want to get another function which is g of x given by f of x plus c, how do I get this function? Now, y is equal to f of x is given. This curve is given to us, f of x. Students, please follow this concept carefully. This is very much required in kinematics. All right, whatever I'm doing now is very much required in kinematics. All right. I've got some random curve like this, which is given by, which is a curve of f of x. Graph of f of x is given. I want graph of g of x, which is transformed from f of which is transformed, which we get it by transforming f of x like this. That means I add constant c to f of x. I want g of x. Given is f of x. F of x is given. All I have to do is add constant to it to get g of x. So how do I plot g of x? I'll come back to you, Bhavna. Let's that question I'll answer it to you. Let's focus on this first. All right. If value of c is 0, it passes through origin. C decides the intercept, M decides the angle. All right. C decides the intercept, M decides the angle which the line makes with the x-axis. So if C is 0, it passes through origin. And if M, tan inverse M will give you the angle it makes with the x-axis. All right. Now let's come back to this one. So I've got a function g of x I can obtain. See, for any value of x, I have f of x already is given to me. So I don't have to bother about what f of x is. I have to add a constant to it. So if constant is positive, I push it up. I will add this constant to this way. For any other value of x, I know f of x, I'll add constant to it. For any other value of x, I know f of x, I'll add constant to it. Any other value of x, I know f of x, I'll add constant to it. So I'll get a function this way. That means all I have to do is push this f of x by 1 unit upward. If I know f of x, I can get g of x by just pushing it upward. In such cases, f of x is called a parent function, g of x is called a derived function or a daughter function. So f of x, given f of x, if I add c to it, c naught to it, I push it up by c naught units upward and get g of x. Now this is my g of x. Now if I want g of x, given f of x minus c naught is greater than 0. Minus c naught. So what I do, I take this f of x, I pull it down by c naught. I get h of x. H of x, f of x minus c naught. F of x is already I know. All right, I don't have to worry about how the f of x looks like. I know how it looks like. Once I know how it looks like, I can say how g of x or h of x look like. All right. So given f of x, I repeat, f of x is given, the structure is given, the curve is given, the graph is given. From that, as a parent function, I can get the daughter function by just pushing the function upward and downward. If f of x is given, f of x plus c is pushing it upward, f of x minus c is pushing it downward. All right. So this is pushing it upward, this is pushing it downward. Please take a snapshot of this one. It's going to be very useful in kinematics. In fact, whole of mechanics is going to be useful whenever graphs come, but especially we're going to start with kinematics. C could be any value. 1, 2, 3, 4, root 2, root 3, minus 1, minus 2, anything. It could be anything. Oh, C is greater than 0. It could be 2, 1, 1.2, 1.5, any value. F of x plus 2 would be this function. F of x plus 3 would be this function. F of x minus 1, minus 2, minus 3, minus 4, minus 5, so on. So C could be any value. C is generic value. Yes, they will give that. No, they may not give that. One more thing, students. Students, you will not have questions always on numerical values. You will have questions which are called symbolic, in symbolic form. So such questions you require to work out only in terms of symbols. So you'll have to start getting used to work with symbols itself. You will have numericals, but you'll have very less numericals compared to having questions having symbols. So you'll have more of symbolic questions than numericals. So don't think whether C is given or not. C could be any value. But if C is given, well and good. But if C is not given, C is positive, I push it upward. C is negative, I push it downward. But I have to work with symbols as well. Okay. All right. C, yeah, we will now see how the C is coming into picture. All right. I know y is equal to x looks like this, and y is equal to minus x. How does y is equal to minus x look like? Slope is minus 1. So tan inverse of minus 1, which is, what is tan inverse of minus 1? Can you think of that? Or can you just use yesterday's geometry and tell me the answer? I'll give you the options. 45 degrees, 135 degrees, 60 degrees, 60, 30 degrees. All right, pretty easy options. You can easily get it. It's odd and out. Pretty easy options I've given you. Can you tell me what is tan inverse minus 1? Either you can use yesterday's geometry or from memory. Okay, tan inverse 1 is 45. Excellent, Bhavna. Very good. Excellent. Omkar, excellent. Oh, no, Omkar. Think of it. Think of it. Bhavesh is excellent. Omkar, please think of it. Tan inverse 1 is 45. Look at the students. I had a circle. I draw a tangent to it. This is my unit radius. Intersection of this radial line with the tangent line is tan inverse, tan theta. So if this tan inverse is minus 1 is somewhere here, minus 1. So this is my radial line. This is minus 1. So this angle would be, this is 45, 90 plus 45, 135. All right. Yesterday's geometry will help you telling the answer, or from memory you can tell me the answer. But you have to remember these values. Minus 1, minus root 3, 1 by root 3. These standard values, there is a small table I'll give you. I'll send it as a PDF. Or you can refer your 10th class textbook. You will have it in that. All right. So that would be 135 degrees. That means So this is my -1. All right. So let us plot some curves quickly. Y is equal to x plus 2. How do I do it? I know what is x. I know this is x. X plus 2 would be pushing it 2 units upwards. This would be 2 units. X minus 2. How do you plot x minus 2? Do I pull it down or pull it up? Push it up. All right, good. Someone already says down. I put it down because it is negative, -2. Previously, how were we plotting? I was saying that this is an intercept. This is an intercept and this is a slope. But now I'm not doing that. I said, I know y is equal to x. Y is equal to x ఎలా కనిపిస్తుంది నాకు తెలుసు. ఇలా ఉంది y is equal to x. దానికి నేను కాన్స్టెంట్ యాడ్ చేస్తే ఆర్ సబ్ట్రాక్ట్ చేస్తే పైకైనా వెళ్తుంది కిందకైనా వస్తుంది. All I have to do is just push it up or push it down. Pull it down. Right. Now let us plot y is equal to -x plus 1 and y is equal to -x plus 2. Y is equal to x plus x minus 1. ఇవన్నీ ప్లాట్ చేద్దాము ఒకటే గ్రాఫ్ లో. ఎలా చేస్తారు? y is equal to x minus 1. x ఇలా ఉంటుంది, x minus 1 ఇలా ఉంటుంది. So this is -1. Minus x plus 1. Minus x ఇలా ఉంటుంది. దానికి -x ఇలా ఉంటుంది. దానికి 1 తో పుష్ చేస్తాను. This is -x1, -x plus 1. Second graph, first graph, first graph, second graph. Third graph ఎలా ఉంటుంది? -x plus 2. -x ఎలా ఉంది? ఇలా ఉంటుంది. Making an angle of 135 degrees. I push it by 2 units. So I get this graph. I'm pushing it or putting it up, pushing it up or putting it down, depending on whether this constant is added to my parent function or not. If it is added, I'm pushing it up. My parent function f of x unte. If it is added, I'm pushing it up. My parent function f of x unte. If it's subtracted, I'm pulling it down. All right. So my parent function over here is -x. So -x unte, -x నాకు ఎలా ఉంటుంది నాకు తెలుసు. Making an angle of 135 degrees with x-axis when passing through origin. That's my parent function. ఆ పేరెంట్ ఫంక్షన్ తెలిసాక ప్లస్ 2 చేస్తే నాకు ఐ పుష్ ఇట్ అప్ బై 2 units. +1 చేస్తే ఐ పుష్ ఇట్ అప్ బై 1 unit. If I do -1, that will come down by 1 unit. All right. Now we have got around 6 or 7 parent functions in physics. ఆ 6 and 7 parent functions మనం మాస్టర్ చేసుకుంటే you can plot, you can anatomize or you can analyze any time graph in our syllabus. మన సిలబస్ లో అనలైజ్ చేయడానికి పేరెంట్ ఫంక్షన్స్ x ఒకటి ఉంది, x² ఒకటి ఉంది, 1/x ఒకటి ఉంది, e power x ఉంది, log x ఉంది, tan x ఉంది, sin x ఉంది, cot x ఉంది, cos x ఉంది. All right, so you got certain parent functions. Once you analyze these parent functions, your graphical analysis is almost done. All right, so we have seen, so let's now close this with a statement that if I add a constant to a function or subtract a constant to a function, I push it up or pull it down to get a new function from the parent function. ఆ పేరెంట్ ఫంక్షన్ ఎలా ఉంటుంది నాకు తెలిసి ఉండాలి. అది చాలా సింపుల్ ఉన్నాయి ఫంక్షన్స్. x² 1/x e power x 1/1 plus x² and trig. అంతే, ఇవే ఉన్నాయి పేరెంట్ ఫంక్షన్స్ మనకి ఫిజిక్స్ లో. You will not have anything more than this. So if I say graphical analysis, it will be confined or ఎన్కాప్సులేటెడ్ ఆర్ దీంట్లోనే ఉంటాయి మీకు గ్రాఫిక్ అనాలిసిస్. ఈ గ్రాఫ్స్ ని మాస్టర్ చేసుకుంటే అన్ని వచ్చేస్తాయి. కానీ ఈ గ్రాఫ్ మాస్టర్ చేయడానికి కొంచెం టైం పడుతుంది. ఇట్ విల్ టేక్ సమ్ టైమ్ ఫర్ యూ టు గెట్ యూస్ టు సచ్ థాట్ ప్రాసెస్. ఆల్రైట్. సో టుమారో విల్ సీ హౌ టు ట్రాన్స్లేట్ ఇట్ హారిజాంటలీ. ఏం చేస్తే హారిజాంటల్ ట్రాన్స్లేట్ అవుతుంది. See, when I asked you to plot root 3 of x plus 1, what did we do? We expanded it. Root 3x plus root 3. ఒక స్టెప్ వేస్ట్ అయింది మనకి. But if I know the horizontal transformation, horizontal pushing or pulling, I can quickly plot this just by looking at this x. X నాకు తెలిస్తే x root of 3 of x plus 1 quickly ఇలా plot చేసుకోవచ్చు. Alright, so root 3 plus root 3 of x plus 1 is easily plotted if I know the transformations, rather than how to plot a straight line. Straight line no రెండు easy. Using the straight line concept కూడా ఈజీనే, ట్రాన్స్ఫర్మేషన్ చేస్తే కూడా ఈజీనే. కానీ వేరే ఫంక్షన్స్ కి, వేరే పేరెంట్ ఫంక్షన్స్ కి ప్లాట్ చేయాలంటే without transformations, it is a hell. It will take hours together to plot a function without transformations. Alright, so hope you have understood all that I have spoken. If you have any doubts in particular, can you please put it on the chat box? Right, good. You've understood, Ifra, good. Okay, what is middle line? This is minus x. This is minus x plus 1, minus x plus 2. ఇదేమో x, ఇదేమో minus x minus 1. Alright, these are the graphs we have plotted by transformations. And understand that point, that intersection of constant coordinate lines is, yes, we'll start differentiation tomorrow. Okay, f of x is not, you haven't understood, no? Okay, I'll explain f of x again tomorrow. What I mean by f of x, that's okay. So we'll wind up now. Bhavana, I'll explain, please raise this doubt again tomorrow. I'll start with this doubt itself. f of x ఏంటి అని నేను చెప్తాను. Yes, Bhavyashri, we'll start with differentiation tomorrow. At the end of the class, we'll start with differentiation. All right. I would like Chandrika ma'am to take over, ma'am. Over to you, ma'am.
Yes, sir. Thank you, sir. Now
Thank you.
I would like to invite Prachi ma'am to continue the session.
Hello, everyone. I hope you can see my video and you can hear me, right? Yes, ma'am, just confirm whether you are able to see my video and also my voice is clear. Is it
Yes,
clear?
ma'am. Yes, ma'am, your voice is clear and your screen is also being shared, I think.
Okay.
Yeah.
Okay, students. So let's begin with today's session. So first of all, let's take our attendance who all are there in the class. So you have to just type your names and I'll call out the students and I'll put up the questions related to whatever we have done in the previous session. Now, before that, all of you just close your eyes, take 2 deep breaths. So just close your eyes, take 2 deep breaths and come to the chemistry class. So because just now you did the math class, so yes, it's important. Just keep that aside and now come back to the chemistry class and try to recall all the things that we did in the last 2 sessions. Because now maybe I'll be taking your name and you will have to answer those questions. So quickly, yes, Bhavna is there. Who else? You have to type your name and type Y. So type Y and your name. Yes, I'm seeing the chat on my phone. So yes, Bhavna is there. Fatima is there. So yes, I know Fatima and Bhavna, yes, you were responding yesterday also. What about others? You have to be very quick so that we can learn as much as possible, because the time is limited. So if you will be quick, then we can move forward with our questions, recall, and then we'll learn the new things. Yes, apart from Bhavna and Fatima, Ashrita, if I am pronunciating it right? It's Ashrita, right? Who else? I can see there are more than 10 students. So I just have got the name of just 3 students. I can see just 3 students have replied. You can send the messages in the meeting chat, right? I can see it. Because then I'll not know who is just keeping the phone aside and listening. So to know you are involved in the session, we'll be cross questioning and I'll be checking in the middle of the session. Bhavyashri is there, Manaswi is there. Yes. So now how many students we have got? Yes, I need more names. I know there are more students, so you have to be quick with your typing and confirm your presence in the class. And then we'll do the quick recall. Yes. Manashwi, Bhavyashri is there, Bhavda is there, Ashrita is there, Fatima is there. So all girls, they have registered their name in the chat. So we'll not be spending much time on this. And now let's begin with the recall. So what have we learned in the previous session? We have learned about what the matter was and how do we classify the matter. So yes, as you can see that we did the classification as solid, liquid and gases, and also we classified them as pure substances and mixtures. I'm constantly looking at the chat box. Okay, Rakshita is there. So I'll be doing the recall also and I'll be seeing your presence also here. So you have to type your name for sure. Yes. Now, yesterday, once we have learned about the matter, now the next question was, if I have any matter and I want to study it, then for that I must know about their physical properties and their chemical properties. So first we learned about the measurement of the physical properties. Now, to learn about the physical properties, we have to adopt a system which is accepted by all. So there we learned about the International System of Unit, which is the SI system. And in the SI system, we have 7 base units. And those base units were length, mass, time, electric current, temperature, amount of substance, and luminous intensity, as you can see on the screen. And here are the symbols for those quantities, which is for length, we have small m, then for mass, we have small m, for time, we have small t, for electric current, as you may know, we have capital I. These are the symbols of the quantity. But what we have to focus on is what is the symbol for the unit, right? So here, first let's finish the symbol for the quantity. So as Bhavna was confused in the last session, like what is the symbol for the amount of substance? So the symbol for the amount of substance is N. And your N in whole of the chemistry will from now will denote the number of moles, which is the base unit for the amount of substance. Yes, Deepika and Rakshita. So here, now we should know what are the units that we are using for these quantities. So for length, we have meter. For mass, we have kg. For time, we have second. For current, we have ampere. For temperature, we have Kelvin. And for amount of substance, we have mole. And then for the luminous intensity, we have candela, that is CD. So these are the units for the quantities, the base quantities that we will be learning. Now, the thing is, when we are learning about all these things in chemistry, now once we go to the lab, the amount of substance or the amount of solution that we will be dealing with will be very less, right? So yes, we have to learn about what are the other units or what are the prefixes and their multiples. So as I have told you, if you have pico, then it is 10 raised to the power minus 12. If you have nano, then it is 10 raised to the power minus 9 and so on. So we will have micro, milli, centi, deci, deca, hecto, kilo and mega. So now if someone says 1 picometer, then it means it is equals to 10 raised to the power minus 12 meter. So this is the one you will be seeing very often. And other ways, other things that you may see is micro, milli, centi, deci, and kilo. So these are the prefixes and the multiples that we will be using. So from now, you should know what's the relationship between when, if I say picometer, centimeter, kilometer, so you should know what is the multiple for the particular prefix. Now, after that, we learned about some of the SI units and the derived units. So in that, we saw mass and temperature. So these were the SI units, and the derived units were volume and density. So we learned about the volume and density, where we saw that volume is the cube of length. So if I want to write the unit in SI system, then it will be meter cube. And then we saw the different conversions, that is going from liter to decimeter cube, from milliliter to centimeter cube. And as I have told you, let's suppose if I have a cube which has the dimension 1 decimeter, 1 decimeter to 1 decimeter, then the amount of substance that will come in it will be equals to 1 liter. So there we learned that 1 liter is equals to 1 decimeter cube, and 1 ml will be equals to 1 centimeter cube. And as you know that 1 liter is equals to 1000 ml, I hope now you can write what is the relationship between 1 liter and the centimeter cube. So these things you have to do very quickly, and you have to revise them again and again so that these things don't take much of your time. Now, when we were learning about the density, then I told you that density is equals to mass upon volume, as you may know, and the unit will be kg per meter cube. And I have asked you what it will be in the terms of gram per centimeter cube, or we say gram per ml. So yes, Bhavyashri, what will be the answer? If I'll go from kg meter cube, so 1 kg meter cube will be equals to how many gram per centimeter cube? Yes, quickly tell me your answer. So this answer will be given by Bhavyashri. Yes, Bhavyashri, we will move on, but we are waiting for your answer. So is it 1000? Okay. Okay, Fatim has also answered this. So let's do it. Yes, Manasvi, what will be the answer? 1 kg per meter cube will be equals to how many gram per centimeter cube? So if I want to go from kg to gram, then what I have to do? I'll have to put here 1000 grams, right? Now, if I'm going from meter cube to centimeter cube, so meter cube, how you have to do in exam if you forget it. So what I am doing is I have 1 kg meter cube. So now I have to convert into gram per centimeter cube. So 1 kg is equals to 1000 gram. And I hope you know that the relationship between meter and centimeter is 1 meter is equals to 100 centimeter. So now here what we have, meter cube. So how many 100 we'll put? 100 into 100 into 100, because we have 1 meter into 1 meter into 1 meter. And each meter will be equals to 100 centimeter. So how can I write this? It will be equals to 10 raised to the power 6 centimeter cube. So now quickly tell me the answer. Yes. Now the answer will be 10 raised to the power. So this will be written as 10 raised to the power 3. So how can I write it? 10 raised to the power 3 minus 6, which is equals to minus 3 gram per centimeter cube. So you should not have any confusion when you are converting the units, which will be required so many times in so many numericals. So you have to correct it, Bhavyashri. It should have been 10 raised to the power minus 3 gram per centimeter cube. And here, as you can see, what was the process? How did we go from 1 kg per meter cube to gram per centimeter cube? If this is clear, then the other thing that I have asked you, what is the relationship between 1 kg and milligram? Yes, now this will be answered by Deepika. Yes, Deepika, what should be our answer? If I want to go from kg to mg, then 1 kg will be equals to how many milligrams? This means milligrams. So yes, Deepika will be answering this question for us, and then we will quickly move on. Yes, Fatima, Deepika has to answer this, right? I'll bring other problems for you also. So yes, Deepika, what would be the answer for this? That is 1 kg is equals to how many milligrams? Yes, Bhavyashri has also answered this. So Deepika, if you are there, you have to answer there. I'll be waiting for your answer in the chat box. So with this, we'll move on to, so yes, we have to see this. What is the relationship between, so Deepika has answered this as 1000. So how is it 1000? You don't have to just give the random answer. See, I did the whole thing here, correct? So you have to do the things in the same sequence. Let's suppose if you don't know anything at all, but if you know what is 1 kg in grams, and also if you know what is gram in mg, now using that information also, you can convert kg to milligrams. So you have to do it, Deepika. I want the right answer from you. So by the end of the session, we'll come back again to this conversion till you get it right. Now, let's focus on the next topic that we will be learning today. So now, after learning about the matter and the international system of unit and just learning about the basic things, how are we going to convert one unit to the other so that we can handle the numerical with ease. Now, after learning about all those things, what we have to learn about is we have to learn about the laws of chemical combination. We will be learning about the laws of chemical combination. Now here, we will be learning about 5 basic laws. So the first law that we will be learning about is the law of conservation of energy. Law of conservation of mass. So energy we will be learning in physics. So here we will be learning about the law of conservation of mass. Then after that, we will learn about law of definite proportion. Then the third law that we will be learning about is the law of multiple proportion. And then we will see Gay-Lussac's law. Gay-Lussac's law of gaseous volumes. And then finally, we will move on to the Avogadro law. So these are the 5 laws that we will have to learn so as to understand rest of the things in the chemistry in this chapter also and in other unit also. So let's begin with the law of conservation of mass. Law of conservation of mass. So this is a very simple law. So as the name is conservation of mass. So what does the word conservation means? That something is being protected, right? So here what is protected? Mass is protected. So what does this law says? So basically this law was given by Antony Lavoisier, who was known as the father of modern chemistry. So he was the one who performed so many experiments, and then he came with this law, which is the law of conservation of mass. And this law says that the mass can neither be created nor it can be destroyed. So this law seems similar to the law of conservation of energy, right? Which says that energy can neither be created nor destroyed. In the similar way, this law says that mass can neither be created nor destroyed. What will happen then? It will just be transformed from one form to other. Transformed from one form to other. So this is the definition. Now what is the use of learning this law here in chemistry? So where are we going to use this law? So your answer should be this whole definition that you can see on the screen is, that is, mass can neither be created nor destroyed. Okay, fine. It is only transformed from one form to other, right? Now, how are we going to use this in chemistry? So basically this whole thing, what does it mean is, that is the mass of product will be equals to the mass of reactant. And this is a very important statement for you. So you have to put a box and put stars on this statement. That is, the mass of the product will be equals to the mass of the reactant, or we can say the other way, that mass of the reactant will be equals to the mass of the product. Now, what's the use of this? The use is that whenever we are doing any reaction, then we will see that whatever mass we took, it will be transformed to some other compounds. But in that whole process, whatever mass we have started with will remain the same. And that is the reason that we balance the chemical reaction. There we are following the law of conservation of mass, because in that case the mass of the product has to be equal to the mass of reactant. For example, let's suppose if I am burning methane, right? So methane is CH4. Okay, now if I burn, so whenever somebody says you burning, then what you have to do is you have to write the reaction with oxygen, right? Now, whenever we are burning any hydrocarbon, so from here you should know it that the only two products that I am going to get is carbon dioxide and water. So what I'll get carbon dioxide and water, right? So now the thing is, as we have to follow the law of conservation of mass, now we have to balance this equation. Now, there is a shortcut to balance this equation. So the first method, the standard method, is we just have to pick the molecule which have the maximum number of atoms, right? Now, if you don't want to go that way and you see a reaction of a hydrocarbon with that of oxygen, So the method that I'm going to tell you is for the balancing of the reaction in which you are burning any hydrocarbon, or in the other words, we can say that you are looking or you have to balance the equation in which we have a hydrocarbon, which is the compounds that will have carbon and hydrogens only, and they are reacting with oxygen. So the first thing you should know that the products will always be carbon dioxide and water. And the number of carbon dioxide molecules that will be produced in this reaction will be equal to the number of carbons that is present in this hydrocarbon. So quickly tell me, what is the number of carbons in this reaction? Yes. Quickly tell me, what is the number of carbons in this reaction? Yes, Deepika, what's the number of carbons in this reaction? Ashrita, if I am pronunciating it right, Ashrita, what is the number of carbon in this reaction? Yes, the number of carbons here is 1. So the coefficient that I'll put here is 1. So obviously, we can leave it as it is. Now, the number of water molecules that will be produced in this reaction will be the half of the number of hydrogens that are present here. So what is the number of hydrogens that are present here? So the number of hydrogens here is 4. So the number of water molecules that will be produced is, so quickly type your answer. What will be the number of water molecules that will be produced here? Yes, this will be 2. Now, easily you can balance the oxygen. So here, what is the number of oxygen? We have 2 oxygen, and from here we will have 2 oxygen because one water molecule has 1 oxygen. So 2 water molecules will have 2 oxygen. So I have 4 oxygen here. So to make it 4, I'll put 2 here. Now let's suppose in this kind of a reaction, somebody says you that the amount of CH4 that was taken is 16 grams. The amount of oxygen that was taken is 64 grams, and the amount of carbon dioxide that was produced is 44 grams. Now you have to tell me in the chat box what will be the mass of water that will be produced. So quickly do your calculation following the law of conservation of mass and tell me what will be the amount of water that will be produced. Yes. Yes, Rakshita says it is 36. 36, yes. The amount of water will be 36. So now as you can see on both of the sides, we have 80 grams, and on this side also I'll have 80 grams, right? Because if I'll add both of these, I'll get 80 grams. So obviously on this side also, the amount has to be 80 grams, and I already knew that what is the amount of CO2. So simply what I was supposed to do is I had to subtract 44 from 80. Okay, it's Rakshit. Okay, I'm sorry. So yes, so this was a very simple equation and this was a very basic problem. Now the problems can get complicated as the level will increase. So the other kind of problem you can get is, let's suppose you have 0.005. So you have to write this question, which is, let's suppose you have, so here I am writing the question is, what mass of AgNO3, which is silver nitrate, reacts with 0.0058 kg of NaCl to give 14.35 grams of AgCl and 8.5 grams of NaNO3. So yes, you have to do this problem and we'll see what are the answers. So this is your homework and you have to solve this problem. This is also a very simple and the basic problem. So I hope you all will be able to do it. Now with this, let's move on to the next law, which is the law of definite proportion. So how many of you know what this law says? So just type yes in the chat box. Yes, Rakshita. So what this law says? This law says that elements, they combine to form molecules in a fixed ratio of their mass. What I am saying is that the elements, they will combine with each other to form a molecule in a fixed ratio of their masses, and the ratios remain constant irrespective of their source. So this is what the standard definition is. What it says elements combine to form what they'll form. They'll form molecules. They will form molecules in fixed ratio of their masses. So you can look for the exact words in your book, but I'm just writing the definitions here for your reference. So elements combine to form molecules in fixed ratio of their masses, and ratio remains constant irrespective of their source. Now the thing is, this statement might seem very easy for you right now, right? Because now we know so many things. We know the basic chemistry which you might have learned in your 9th and 10th standard. But at that time, in the starting, when the experiments were conducted, they didn't know nothing about all these things. They didn't know what exactly water consists of. But at that time, the law that they came up with is the law of definite proportion. So what does it mean in simple languages? For let's take water. So water is H2O. So here the mass of water is 2 grams and the mass of oxygen is 16 grams, right? So here, what is the simple ratio of their masses is 1:8, right? Now let's suppose I bring this water from sea, or let's suppose if I am forming water in lab by the reaction of oxygen with hydrogen, right? If I am forming water in lab by passing an electric discharge through these gases, which is hydrogen and oxygen, then in that case also I am going to get water. Now, whether I see the water, whether I look at the water which I am getting from sea, or whether I look at the water which I am preparing in the lab, the both of them will have the same elements, that is oxygen and hydrogen, and the ratio of their masses will be same. So that's what it is saying, that the elements combine to form molecules in fixed ratio of their masses, and the ratio remains constant irrespective of the source. So it does not depend whether the water was prepared in lab or it was brought from the nature. For example, let's suppose if I bring it from some lake or sea, or if I take rainwater, then what will remain same is that the ratio of their masses will remain same, and it will be same for whatever, irrespective of the source. So this, I hope there is no doubt in the law of definite proportion. Now, the next law, which is very important for us and the little difficult to understand from the textbook, is law of multiple proportion. So first, here I'll write some example. So just quickly give me the example of molecules which can form by the combination of carbon and oxygen. And also just tell me, okay, first let's start with carbon and oxygen. So just quickly type in the chat box, what are the molecules that comes to your mind which can be formed by the combination of oxygen and carbon? Just oxygen and carbon. Yes, we can have carbon monoxide and we can have carbon dioxide. Yes, let's take these two examples, right? So we can have carbon monoxide and carbon dioxide. So what this law says? This law says that when two elements, when two elements combine to form two or more than two compounds, then the mass of one element that is combining with the fixed mass of other element will always be in simple ratio. This is the definition. Now I'll explain you the definition with these examples. So here the mass of carbon is 12 and in this also the mass of carbon is 12. Now in this one, that is carbon monoxide, the mass of oxygen is 16 and here the mass of oxygen is 16 into 2, which is 32. So instead of writing 32, I am writing 16 into 2. So now what the definition says, when two elements, they combine with each other to form two or more than two products, then the mass of one element that combined with fixed mass of other elements. So we have fixed mass of carbon. Then it says that the mass of this element, which is combining with the element whose mass we have fixed, they will be in simple ratio. They will be in simple ratio. Now what's the ratios? It will be 1:2, right? 16 divided by 16 into 2. So 16 cancels by 16. So we have 1:2. So do you want me to write the definition? So if you want the definition, then I'll write it here. Otherwise, we'll see one more example and then we will move ahead. Okay, I'll write the definition. So what it says when two elements combine to form two or more compounds. So just understand it with this example. So here what we are saying is when two elements, they combine to form two or more compounds, one element, then mass of one element that combines with fixed mass of other element will be in, will always, we'll write will always. Will always be in simple ratio. So just read the definition and relate it with this example. What it is saying, when two elements combine to form two or more compounds, then the mass of one element that combines with fixed mass of other element will always be in simple ratio. Now you could get a question based on this, is like you will be given certain compounds and they may ask you like whether or which among the following is following the law of multiple proportion. So we'll understand this quickly by taking other example also. So just write, okay, let's take other element. Let's take nitrogen and oxygen. So quickly tell me the compounds with nitrogen and oxygen. So here is one important thing which you have to take care is you have to fix the mass of one element. Yes, you have to type in the chat the molecules which you can get by the combination of nitrogen and oxygen. Yes, quickly. Yes, Harshit. Quickly, Bhavna, Harshit, Fatima. Just quickly give me 3-4 examples of the compounds. If you are not giving it, I'll write it on my own. Okay, let's take for N, we will take it is combining with oxygen. So one is given to us is NO3. Okay, we will take N2O, N3O3. Okay, Fatima, is there any compound possible? N3O3, NO2. Okay, we'll just take these three. So here, what we have to do is, first we have to fix the mass of one element. So let's choose nitrogen, or you can take oxygen also, but we have to fix the mass, because what we can see in all these three molecules is, here we have one nitrogen, and as we know the mass of nitrogen is 14. Here what we will have double of it, right? 14 into 2, that is 28, and here we have 14. So yes, the mass is not fixed, neither for oxygen. So here for oxygen, we will have 16 into 3, that is 48. Here we will have 16, and again here we will have 2 into 16. So none of the masses are, so neither for nitrogen, neither for oxygen, the masses are constant, right? So first we will select one element. So I am selecting nitrogen here. So I'll fix the mass for nitrogen. So how I'll fix that? So as I can see, we have two nitrogen here. So we will make the mass same by multiplying these two with 2, right? That's what we will do. So now here we will have N2O6. Here we simply have N2O, and this becomes N2O4. Now quickly tell me, whether do we have oxygen in, if I take the ratio of masses of oxygen in NO3, N2O and NO2, are they in simple ratio? Yes, you have to, yes. Yes, they are in simple ratio. So 1:4, right? Similarly, you can do it for water and H2O2. You can do it for water and H2O2. So here what you can see is that they are in ratio 1:2. Whose mass we are looking at? We are looking at the mass of oxygen. The very important point that you can miss is that not fixing the mass of one of the element. So you have to fix the mass of one of the element, and then only you can compare the mass of the other element. Yes, that way also you can write we are taking 2NO2, right? Yes. So now we will move on to the, so these three laws are done. Among these, the one which was very important for you to understand is the law of multiple proportion. And this law says that we have to fix the mass of the one element, and then if we compare the mass of the other element, then it will be in the simple ratio. Now, the fourth law is Gay-Lussac's law of gaseous volumes. What does it say? So here, now the fourth one, yes, we'll take your questions at the end. So when we'll have 5 minutes, I'll take your questions. So we have Gay-Lussac's law of gaseous volumes. So what it says is gases, they combine in simple ratio of their volume at constant temperature and pressure. So this is the definition. This is the statement, we can say, not definition. So this is the statement for the Gay-Lussac's law of gaseous volume. What it says that gases, they combine in simple ratio of their volumes at constant temperature and pressure. What does that mean? So let's understand this by an example. So let's take the simple equation that we saw just now. So hydrogen is reacting with oxygen and it will give me water, right? So now we know, in today's time we know, okay, hydrogen, how does it look like? Okay, it will have two atoms of hydrogens which will come together. But these things were not known at that time. Like, if I am taking a certain volume of oxygen, what is there in that? But what they observed is, if they took 100 ml of hydrogen, what they observed is that if they took 100 ml of hydrogen, then the amount of oxygen that was required was 50 ml. Now, if I take the ratio, then 100 ratio 50, what it will be? 2 ratio 1. And the important condition is at a constant temperature and pressure. So what it is saying is, gases, they combine in simple ratio of their volumes. Similarly, let's suppose if I take the volume of hydrogen as 500 ml, then what will be the amount of oxygen that will be required? So according to them, if they might have performed the experiment with 500 ml, they would have got it as 250 ml of oxygen would have been required in this experiment. Right now, we can relate it like this, but at that time, these things were not clear that exactly what these gases consisted of. So I hope this is clear to you. And then we'll see the last law and we will finish these laws. Now the last law is Avogadro law. So you just should know this law and we'll see these all things, some of the things which are related to Avogadro law. Because when these laws were given, there were many things which were not known at that time. That is, people didn't know that electrons existed, proton existed, and what exactly these gases or any compound or molecules are consisting of, right? So what it says is equal volume of all gases, at same, so for temperature I am writing T and for pressure I'll write P. So equal volume of all gases as same temperature and pressure should contain equal number of molecules. Now, what does that mean? What it is saying, that equal volume of all gases at same temperature and pressure should contain equal number of molecules. So this we have to understand. At that time, they didn't know much about the things like how I can write the equation right here. Now, looking at this, what I can say is that 2 volumes of hydrogen is reacting with 1 volume of oxygen. And it is giving me 2 volumes of water. Right? That's how I can write this equation, that I am taking 2 volumes of hydrogen and it is reacting with 1 volume of oxygen, because water has a formula that is H2O. So here I can see that it is having the ratio of water to oxygen is 2:1. So here 2 volumes of hydrogen will react with 1 volume of oxygen. Now this we will understand in detail in the next class what exactly this law means. This is same related to when we will learn further, we'll see that all gases at the standard temperature and pressure will occupy the volume of 22.4 liters, and then the definition was changed, so then we started using 22.7. So this is the same law that we will be learning again. So it's very important to understand this. What exactly does it mean? Yes. So now, have you noted the definition? So the definition part is over. We'll just learn about we'll just see what exactly does it mean. What we learn about the Avogadro law, and then what are we going to learn in the next class? So I'll tell you what are the things we will learn. We will learn about the atomic mass and molecular mass. We will learn about atomic mass and molecular mass. So when we are learning about the atomic mass, there we will come across the number of moles. We'll come across the moles. And then from there, we'll see what is atomic mass, what is moles, what is molar mass, what is molecular mass, and what is formula mass. Right? Now, we will be dealing with lot of things when you will do your practicals. So the important thing for us to know is how do I tell the amount of substance in moles? For any substance that you have, then how do you tell it in the number of moles? And if I am telling, if for the amount of substance, the unit I am using is moles, then it's important for us to understand why am I using moles? From where did this unit come? Why are we not using any other number or any other unit? So there we will see how did we come up with the mole and how using this value makes all of the things easy for us. So these are the things. Okay. So now we'll take the doubts. So we have completed with the laws of chemical combination. So now in next class, we'll learn about the atomic and the molecular masses. And after that, we'll see about the limiting reagents and some concentration terms. Then we will be done with the basic concepts. So let's see the questions that you have. So yes, Fatima, you want one more example for? Explain third law. Okay, so you have confusions with some of these laws, right? So what we'll do is, okay, most of you have the confusions with the laws. So some of you are saying the third. Okay, I hope this is what you are asking. Okay, this one. Yes, Bhavna, this is what you are asking. Okay, by that time, Fatima is asking for the fourth law. So in fourth law, what it says is, let's suppose, can you give me, okay, here, what they might have done is, let's suppose they started with 100 ml of hydrogen, right? So they have observed is if I take 100 ml of hydrogen, then the amount of oxygen will be 50 ml. It can't be 50.1 or it can't be 30.1, 40.5, 40.3. Because if the amount, or we say the volume of oxygen would have come this, then we couldn't have got the simple ratio of volumes. So they might have performed many experiments with different gases, and what they came up with is that when I am doing the reaction of two gases, then always they are reacting in the simple ratio. The ratio of their volumes will be a simple ratio, right? It will, I hope you have understood this. Let's suppose with this example, let's suppose if I am taking 100 ml of hydrogen, then it will be reacting with 50 ml of oxygen. It won't be reacting with 50.1 or 50.2 or 50.3. That is what their observation is. And then they came up with the law, because they were able to observe the same thing with many reactions, right? Whenever, and with which reactions, in which gases were reacting with each other. See, what you can see here is gaseous volumes. So if they are doing the reaction with two gases, what they observed is that the ratio of their volumes will always be in a simple ratio, right? You can take any other example also. For, let's suppose if I take H2 plus Cl2, right? So I'll get 2HCl, correct? So in this case also, what you'll see is, what is happening here is they are reacting in 1:1. So yes, they might have done this reaction also, and they might have observed this. If I am taking 100 ml of hydrogen, then it is reacting with 100 ml of chlorine. And if I am taking 500 ml of hydrogen, they might have observed that they were requiring 500 ml of chlorine. So with that, they came up with a law that whenever two gases are combining with each other, then they will combining with each other, then the ratio of their volumes will be a simple ratio. Yes. What I can understand, Fatima, is you're trying to ask is, yes, the ratio of their volumes will be a simple ratio, which is 2:1. If there are any other questions, you can put up in the group, and I'll take those questions in the next class. Okay, third law. Okay. See, third law, what it says is, let's suppose if you have two elements and they combine with each other to give you compounds, which they can give combine with each other and give you 2 compounds also, 3 compounds also, 4 compounds also, and 5 compounds also, right? When two elements combine to form 2 or more compounds, the mass of one element that combines with the fixed mass of other element will always be in a simple ratio. So what it says is that to see, what I'll do is I'll come up with the other example and I'll explain you very clearly. I'll come up with one question, and from that you'll be able to understand this. So in next class, I'll come up with the question and this will be clear to you. So it's normal. Usually we get confused with the law of multiple proportion. So yes, we'll see 2 questions related to this, and by doing those, this will be clear to you. Mm-hmm. No, 100 to 100 for this. For when you will be doing the reaction of hydrogen with chlorine, because in that you are getting HCl. Now in HCl, the ratio of hydrogen and chlorine is 1:1, right? So I'll require 1 volume of hydrogen and 1 volume of chlorine. 2:1 is for when I'm reacting hydrogen with oxygen, which is giving me water. And in water, what I can see is that the ratio of hydrogen to water is 2:1. So I would require 2 volumes of hydrogen and 1 volume of oxygen. So yes, rest of the questions you can ask in the group. So I'll clear all those in the next session. Yes, ma'am.
Yes, ma'am. Thank you, ma'am.
Yeah.
Yes. Now I would like to invite Dupinder sir to continue the session.
Hi, hello. Good evening. Am I audible?
Yes, sir, you're audible.
Okay, okay. Hello. Good
Yes,
evening,
sir.
everyone. Seems like you had a very long, tiring session. Hi, hi. Good evening. Good evening. So, the last time when we met, we had discussed about limits, right? We had discussed about limit. Hi, good evening. Hello, good evening. So, I'll just share my screen. Then we are good to go. I hope all of you remember. Hi, hi. Good evening. Okay. Is my screen visible? Hello.
Yes, sir, it is visible.
Okay, okay.
Yes.
Okay, ma'am. Thank you. So yeah, so the previous time we had learned about limits. Uh, I had told you that suppose this is a number line, here is a number x. So we assume a number very small on either side of the number line, and then assume it to uh, for any function. So last time we were discussing something about important concepts of limits. Like we had discussed that if we had something like this, so uh, when we were substituting x tends to 1, so we were able to cancel out this, and so we got this 2. The reason behind it is that we were not talking about the exact number 1 on the number line. So this was the concept I was discussing. So I'll just have a small problem for you to start our today's session. Just after this problem, we'll be continuing with the concept of derivatives. Okay. So the we will be discussing one problem today. Just a problem now. Okay. So could you find the limit of x tends to okay, say x tends to 1. Okay, just a second. Okay, we are good to go after this question. Okay. So could you guys evaluate it or go into a reason about how we can uh, go about it? Am I audible?
Yes, sir, you're audible.
Okay, okay, great, great.
Yes, sir.
So does anyone know the answer over here? Or does anyone know how to proceed basically? Gayatri, Bhavyashri, you were there in the previous classes, right? Rakshit was there, Jyoti was there. Yeah, I remember. Ashrita was there. I remember your names, right? So does anyone know how we could proceed about this question? Okay. No, 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 no. We can't. We can't. Okay, so just reminding you of what we had learned. We are just doing a basic revision over here. Okay. So what we can see, can we factorize? Okay, so first of all, we will try the basic thing only that we were doing previous time. So first of all, you will try to substitute the value. Okay. So first you will try to put the value x is equal to 1 inside this function. But when you put it, you will see it is 1 square minus 2 1 plus 1 whole divided by 1 square minus 4 into 1 plus 3. It will turn out to be 0 by 0. Do you get the problem why we are not able to substitute it? Is everyone able to get it? Yes, exactly. You are correct. Okay, so we now get the point. You are now getting the point why we are not able to do it in the direct way as we used to do it normal polynomial functions. So yeah, we will just continue with the same way. So x square minus 2x plus 1, it will definitely have a factor as x minus 1. So it will be written as x minus 1 squared. Similarly, we have x square minus 4x plus 3. This can be factorized as x minus 1 times x minus 3. So when we try to evaluate its limit, it can be written as limit x tends to 1, x minus 1 squared by x minus 1 and x minus 3. So do you guys get the point? How we could go about it? Please let me know. Gayatri, do you have any idea? Bhavna, Ashrita, Jyoti, Rakshit, Manoj, how we can do it? How we will proceed to this question? Why are you guys not speaking again? Speaking today? Seems like you got quite bored. Okay, so let me know. Okay. So yeah, proceeding in the same way as we used to do it previous time in the previous class, you had remembered it, right? So yeah, it is, we could just cancel out x minus 1 and x minus 1 because x is not 1. That is the concept, right? That if I'm talking about limit x tends to 1, then it is on the either side. It is either left or right on number line. So x is not equal to 1. If x is not equal to 1, I can cancel it out because it is some finite number divided by some finite number. So it will turn out to be x minus 1 divided by x minus 3. So when, oh, okay, x minus 1 divided by x minus 3. Okay, so the answer will be 0. This doesn't mean that 0 divided by 0 is equal to 0. You can't say that, okay? You can't say this. 0 divided by 0 is still not defined. It's just a coincidence that the answer is turning out to be, that the answer here is turning out to be 0. Okay, so seems like you need a bit of revision. So we'll move ahead, okay? Okay, so I'll revise again with another problem of the same kind. Okay. Okay, just a second. Okay, sorry. It's okay. It's minus 1. Okay. So how will we do it? Why is not anyone speaking today? Gayatri, are you there? Fatima, Bhavyashri, Rakshit, Jyoti, Manoj, Ashrita, are you listening? Oh, okay, that is the issue. Okay, okay, I get it. Okay, so you won't be able to speak today. That is the issue. Okay, okay, sure. So let me know how you will proceed to this question. You can let me know in the chat at least. Okay. I get your point. Ma'am, can you please allow them to speak? Uh, can you
Yes, sir.
share the
Yes,
access?
they can unmute, sir. They can unmute. We have given permission, they can unmute, sir.
Okay. Sure.
Yes.
Okay.
Yes.
Okay, sure. So yeah, you can speak now.
So in the previous problem, how did we get that x minus 1 whole square?
Yes. Sorry. X minus 1 whole square. Okay. Yeah.
X square minus 2x plus 1. By that we got x minus 1 whole square. How did we get that?
Actually, okay. There is some issue here. Just a second. Okay. So yeah. So do you know the formula for a minus b whole square? It's
Yes,
a
sir.
square minus 2ab plus b square, right? So instead of a, if you put x, and instead of b, if you put 1. So x minus 1 whole square, that is equal to x square minus 2x plus 1. You can try it. You can put it. Actually, it's a standard format. You might have learned it in your earlier classes. If not, it's easy to recognize. It's a pattern that you will see everywhere. Okay.
Okay, sir. Then down x minus 1 into x minus 3.
Yeah. It's called factorization. Okay. Okay. Sure. I'll write it. 1 second. Okay. Okay. So yeah, how we will do it? So again, we will factorize it, right? We will factorize it and write it as x plus 1 multiplied x plus 4 divided by x plus 1 multiplied x plus 3. Now, if you try to put the value, it will again turn out to be 0 by 0 if you directly try to put the value. But if you try to cancel, it is allowed to cancel. Okay. So it will be 3 divided by 2. So does that mean 0 by 0 is equal to 3 by 2? Can I say that? Can I say that? Is this statement true? Let me know in the chat box or by message how. Okay,
So
yeah.
then may I know how x plus 4 and x plus 4 by x plus 3 will be 3 by 2?
Yes, because the value of x is minus 1. See, we have x plus 4 divided by x plus 3. Okay. So, and its limit is tending to minus 1. So first of all, you will try to uh, put the actual value in the limit. Okay. Like we used to do earlier, the issue was what if we did here? Okay. So the basic method of evaluating limit is that you have this function. Function basically means something in the form of x, okay, y of x, like this you have.
Okay,
So
sir.
here, if you try to directly put the value of x is equal to minus 1, if you directly try to put it in here, you can see it would turn out to be 0 divided by 0. That is actually not defined. Okay. You can try, you can see it. If you substitute the value of minus 1 here and minus 1 here, it will turn out to be 0 by 0. That is actually not defined. Okay. So that is why what we do, we cancel the value, we factorize it, find a common term here, and then we cancel it because, like just we do 5 by 5, 4 by 4. Similarly, we can do x plus 1 divided by x plus 1, provided if x is not equal to minus 1, which is actually it is not. That is the concept of limit. Okay, do you get it?
Yes, sir.
Okay. Okay. So does everyone get this problem? Okay. So please let me know what is the issue, Bhavyashri. You can unmute and speak also. Uh, they have given you the permission right now, the access to speak.
In the previous problem, I have some doubts, sir. Now, no doubt.
Sure, sure.
Clear.
Previous as in that one.
It's
It
also
was
cleared, sir, that you explained how we got x minus 1 whole square.
okay. Okay, it is cleared. Okay, great. So we can move ahead. Are you clear with this problem? Is this problem clear to you? Did you
Yes,
get
sir.
how we did it?
Yes, sir.
Okay, okay. You are a JE aspirant, right? Or are you from Neet? Are you appearing for
JE,
Neet?
sir.
Okay, 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 great, great. Sure, not an issue. Okay. So now that we are familiar with the concept of limit, and previous time we had also learned about what the slope of a line means, right? So we had learned about the slope of a line. So uh, I'll just tell you what I'll just combine these two things and tell you what tangent is. Like for example, we have a curve like this. Okay, it is a curve. We have a point here. So tangent means a line that passes through this point. Okay, it is a line. Actually, I am not sure if. Okay, wait. Actually, it is. I'm not very familiar with the UI here. Okay, still. So you guys can assume this. It is a line. Okay. So this is a line that is touching this curve. This here we have a curve y of x. Like this can be written as a function of x. Okay. So here we have a curve and this line is touching it at this point. So let us call it this point any normal point x comma. So instead of this, let us assume it to be f of x. Okay. Let us assume it to be f of x. Okay, great. So can you tell me if the x coordinate of this point is x, what will be the y coordinate? Can anyone tell that? See, I have a function y that can be written as f of x. F of x can be anything. Like it can be a polynomial, something like this x square minus 2x plus 1. So you input the value and you get the corresponding value of y. Like, did you get it? Okay. So we have a function like this. Function means something you like we had studied earlier, right? Yes, yes, sure. Actually, limit in itself is a chapter of mathematics. So you can directly go to the first exercise. We have completed that much part that you can easily complete your first exercise. Okay. So what we are going to do is so yeah, this is a curve and okay, so yeah. So here we have a curve, okay? So if this point's coordinate is x, okay, we are assuming to be x. So can you tell me what will be its y coordinate? Its y coordinate will be x f of x because y is equal to f of x. We are writing it in that format. Okay. So for our ease, we can just take it something. Okay, so can you tell me a function? Tell me any function, okay? Something easy. Bhavna, tell me a function. Any function of your wish, whichever you want it to be.
Sir, is it should be like a polynomial?
Yes, yes, you can tell polynomial also. Polynomials is easy also. You can tell polynomial. Yes. Tell me an easy
2x
polynomial.
square.
Anything.
2x square
2x square.
plus 5x
Yeah.
plus 6.
Okay, great, great, great. So I am assuming as Bhavna has told me. So I will assume y to be this. Okay. Okay. So if I know the x coordinate, do I know the y coordinate? Bhavna, tell me. If I know the x coordinate, do I know the y coordinate?
Yes, sir.
Okay, great. Great. So I'll term it as x comma y. Okay. And earlier I had taught you, if I have 2 points on the xy plane, this point is x1 comma y1. This point is x2 comma y2. So the line joining these 2 points, the line that is connecting these 2 points, what will be the slope of the line? What will be equal to tan theta? What is tan theta? We had discussed it in the previous class. I hope you have revised it. If not, should I do it again? Please let me know. Should I do it again, or do you remember what was the value of tan theta? Okay, okay. I'll do it again. Not an issue. But guys, please mind it to revise. Otherwise, we will always keep lagging like this. Okay. So this point is x1 comma y1. This point is x2 comma y2. So this length would be equal to y2 minus y1. We had taught you this. Similarly, this base would be x2 minus x1. So the value of tan theta is equal to opposite divided by base. So opposite here would be y2 minus y1, and base here would be x2 minus x1. Are you clear? Is this clear to everyone? Is this clear how this came? Or should I need to derive it again, like I had done in the previous class? Okay, so we know this is x1, we know this is x2. So this length will be x2 minus x1. Okay, similarly, we know this is y2, we know this is y1. So this length between these 2 points along the y, it will be equal to y2 minus y. So through this, we had got this. So are you clear with it? Okay, yeah. Okay, so tell me, are you guys clear with it?
Yes, sir.
Okay, great, great. Good to hear that. Please mind it to revise everything you have done. Okay. So moving ahead, uh, I have 2 points. Okay, I have 2 points on this curve itself. So I know the x1 of this point, and I know the x of this point. Like I know the x coordinates of both of these points. So can I say I have this curve, okay, curve that she had told me, 2x square plus 5x plus 6. So 2x square plus 5x plus 6. Okay, so if I know the x coordinates, if I know the x coordinates, do I immediately know the y coordinates itself? Does everyone agree with it? Because we have this thing, we have this relation. If we know the x coordinate, do we know the y coordinate also? Please let me know.
Yes, sir.
Okay, we have x1, so we have y1 also. Similarly, if we have x2, we have y2 also. So I have 2 points on this curve. So if I have 2 points on this curve, do I have the line joining? I have the line joining these 2 points. I have the tan of its value also, the slope of the line also. Do I have it? Do you guys agree? See, I have x1 and x2 already. I have chosen it to be my favorite value. Tell me any value. Bhavna, tell me any two values. Any two values you want it to be.
2 and 3.
Sorry, could you repeat? Could you repeat?
2 and 3, sir.
Okay, great. So if I know x1, what will be y1? You can just put it here. So it will be 2 into 4 plus 10 plus 6, 16 plus 8, 24, right? Similarly, what will be the value of y2? What will be the value of y2? Let me know. So it will be 2 into 9 plus 15 plus 6. Okay. So 18 plus 21, that's 39. Any problem in till here? Any issues till here? See, I gave you this relation. Okay, I gave you this relation. I have plotted it in the XY curve. I know you guys don't know how to plot it, but that's not an issue. I told you I have taken two values of x1 sorry, two values on the x. So I have taken x1 and x2. So if I know x1 and x2, do I know y1 and y2 immediately? Okay, if I know x1, x2, y1, y2, I know the slope of the line also. How? Because tan theta is equal to y2 minus y1 divided by x2 minus x1. Okay, so just by these 2 points, just by knowing these 2 points, I know the slope of the line. Easy. That's very easy. Okay. So now the thing that I'll do is we will play a small game over here. What we will do, for example, I have this relation that Bhavna had told me. Now what I will do, I will keep one of the points fixed, like she had told me. So I'll keep the first coordinate fixed to what she had told me. What was the first coordinate she gave me? She gave me the first coordinate as 2 and 24. So it will be 2 comma 24, right? X1 comma y1. So it is 2 comma 24. And what I'll do is the other point, I can keep it as a variable. So the other point, I'll keep it as anything x comma y. So do I still know the value of this tangent? Do I still know the slope of this tangent? What do you think? Let me know. Why are you all not speaking today?
Yes, sir.
Bhavna, Bhavyasri, Gayatri, what happened? Why are you not speaking today? Are you
Sir, we are
tired?
checking in chat box.
No.
Hello. Yeah, so what happened? Let me know. Okay. Okay.
Sir,
So
there are some questions in chat box. May you please check it once?
yes.
Thank you, sir.
Oh, actually, there is some issue with the chat box. I'm unable to scroll it. Actually, I'm not able. It is not. Bhavna, no. Bhavna, tangent is not something that only belongs to the circle. Tangent can be drawn on any curve. At any point, it should pass through the direction that the curve is passing. Okay.
Sir, your screen sharing has been stopped.
Yes. Okay.
Oh,
Actually, I had done it purposely. Okay. Yeah. So if I know the value of this x, if I keep this x as a variable, do I know this y also? Yes, I know it. I know it. What will it be? It will be x comma any x comma 2x square plus 5x plus 6. But I'll keep this point constant. So can you still tell me in terms of x? What will be the value of slope? Yes, it is easy because I know that I know the formula is still valid. This formula is still valid. The only thing is that earlier when y2, y1, x2, x1 were constants, they were constant values earlier. Now what is happening? Now the value that was earlier constant, it has changed to be variable. It has come out in terms of x. Everything has changed to x. That is the issue. But still, I can find it in terms of x. I can substitute this value here. So it will be 2x squared plus 5x plus 6. That is y2 minus y1 divided by x2 minus x1. So does everyone get it? Does everyone get how we did it?
Yes, sir.
Okay, you got it, right? Yeah.
Yes, sir.
Okay, great. Because earlier everything was a constant. I have just changed it to this. Okay. Okay. So now what I will see, I'll try to bring this value, try to bring x as close as possible to 2. Can I do that? Is it allowed? First of all, check it. Is it allowed to do? Am I allowed to do it? Okay. So that means what I'm trying to do is like here we have this 2. We have this point 2 comma 24. But the other point I'm choosing on the curve is very, 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 very close to it. Very, very close to it. Okay. So can I say it's so close to so close to 2 that I am trying to put this limit over here. I'm trying to substitute this limit over here. But what happens if we do it directly? What will happen? You try to find the value of slope of the line touching these 2 points. What will happen? You try to substitute the value directly. If you try to do, what will it turn out to be? It turns out to be 0 by 0. You can see it because this value 2x squared plus 5x plus 6, it was itself derived from here. But what we are doing is we brought the second point so close to it that now its slope is not defined. That its slope it is showing to be not defined. But is that actually possible? Can the slope be can the slope be uh, can the slope be not defined? How why will the slope be not defined over here? I am connecting these 2 points. There is a line. There is a line. I am connecting these 2 points. So what is the issue over here?
We should not take the x value as 2 in that equation.
Okay, but like I am seeing how close we can get to 2. See, if x is not close to 2, if it is, let us say if x is 3, 4, 5, then we can easily find. It is very, very easy to solve. But just for experimentation, I am trying to go as close as we can to 2. We can I am trying to go as close as we can to 2. Okay, it is a think of it as an experimentation, as a fun class. We are doing fun in today's class. And at the end of this class, I have a surprise for both JE and NEET aspirants also. Sorry, I forgot to announce it earlier. Okay, do you get it? So just moving with this experimentation, we got something. What did we get? We got that, for example, I have this point 2 comma 24. I bring a point so close to it that the line joining these 2 points, can be regarded the line joining these 2 points can be regarded as a tangent on the curve. Do you understand? This is the basic limit that we are talking about. Limit. I have this curve. I have a point on it. I have. So first of all, I will again revise to you what tangent means. I guess you must have forgotten till now. This is a curve, okay? This is a point. Tangent means a line that only cuts it at one point and goes away. And the direction of the tangent basically means the direction in the which the curve is taking at that point. So what I'm saying is, I take 2 points so close to each other that I impose a limit over there. I impose a limit. I take 2 points so close to each other that the line crossing through these 2 points can be regarded as a tangent on the curve at that point. Is everyone clear here? Please let me know.
Yes, sir.
Yes, sir.
Okay, are you clear? Does anyone have any issue? We can I can clear it now. Please let me know. किसी को कोई प्रॉब्लम है किसी भी टाइप की बता दो. You can either switch on your mic also. You can ask me in the chat also. Okay. So I'll just assume because no one is speaking anything today. Okay, sir. But yes, 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 yes. See, that is the point. Nah, that is the initial concept of limit that we had discussed. Limit means that a number is so close to the other number on the number line that its basic properties or the basic value of the function doesn't change on either side. So that is why either you take a tangent or you take 2 points that are extremely close to each other on that line. How extremely close? I had regarded in the previous class also that the values of x differ by 10 raised to minus million. That means 0 followed by 1 million zeros, 0.1 million zeros, and then a 1. So it's so close to each other. It's so close to each other that that these 2 points, the line touching through them, can be regarded as a single point. Okay, you get it right?
Sir, is 0 by 0 and 0 by infinity both are equal?
Uh, Actually, both of these are not defined. No, 0 by infinity, you said, right?
Sir.
0 by infinity is 0. It has to be 0. This is not defined. 0 by infinity is 0. 0 means like a very small number divided by a very large number. So yeah, it has to be 0. 0 divided by anything is 0, but x can't be 0 over here. Right? Hope you get it. Okay. So moving ahead, okay. So yeah, the curve that she gave me was this. I'll take this point 2 comma 4, sorry, 2 comma 24. Okay. And I'll assume this point to be x comma uh, y, or y also I can write it in the form of x only. Okay. So the line joining these 2 points, the slope of this line it will be equal to 2x square plus 5x plus 6 minus 24 divided by x minus 2. So, so if these points are very close to each other, that means x is tending to 2. X is tending to 2. Mind my words, x is not equal to 2. It is tending to 2. So if x is tending to 2, can I say that the slope of this line is equal to the slope of the tangent? Yes, that is what we had been discussing for the previous 5 minutes. Slope of the line has to be equal to the slope of the tangent. So that means slope of the tangent, that means slope of the tangent is equal to limit x tends to 2, 2x square plus 5x plus 6 minus 24 divided by x minus 2. Does everyone get this point? Does everyone get it? Okay.
Yes, sir.
So if you get it, so this is a problem for you also now. This is a practice problem for you also. Find the slope of the tangent at x is equal to 2. How will you do it? How will you solve this limit? Okay, solve this limit now. How can we bring x near to 2? Yes. So I'm just like this, we have this point 2. Okay. So I'm just trying to bring it so close to 2 that these 2 points, when I connect these 2 points, the line joining them can be treated as a tangent. I know it is not the exact tangent. I know that still. I still know that. But I'm bringing it so close to them that these 2 points can be regarded as a tangent. Okay. Hope you get it. Okay. Okay, sure. But I was told that uh, students are not comfortable in हिंदी. आप सबको आती है क्या हिंदी अच्छे से? अगर आती है तो we can talk in Hindi also. I don't have any issue. Okay, ठीक है. So कैसे करोगे लिमिट इवेल्युएशन? इस लिमिट को कैसे इवेल्युएट करोगे? भावना, you will be the one to tell me. Okay. I remember Bhavna, Gayatri, Bhavyashri, you were in the previous classes. Rakshit was also there, I guess. Ashrita, I don't remember clearly, but I remember all your. So at least कम से कम लिमिट तो इवेल्युएशन कर सकते हो ना? लिमिट इवेल्युएशन तो करोगे, ठीक है? कैसे करोगे इसको? ये हो जाएगा लिमिट x टेंड्स टू 2, 2x स्क्वायर प्लस 5x माइनस 18 डिवाइडेड बाय x माइनस 2. ठीक है? कैसे करोगे बताओ?
Sir, y minus 18.
सॉरी, या इट इज 6 ना. 6 माइनस 24, तो 6 माइनस 24 को मैंने माइनस 18 लिख दिया. 6 माइनस 24 है ना, यहाँ पे ब्रैकेट ओपन कर दिया मैंने. सो ये माइनस 18 आ गया. ठीक है. अब बताओ इस चीज को कैसे इवेलुएट करोगे, ये बताओ.
By
इसकी
factorizing.
एग्जैक्टली फैक्टराइजिंग. हाउ वुड यू फैक्टराइज इट?
We can factorize that equation.
यस, 2x स्क्वायर
Hmm.
प्लस 5x माइनस 18, इसको कैसे फैक्टराइज करोगे बताओ? It can be written as, see, one
Why
thing is very
don't you
very clear to
multiply
you.
all the values in bracket
One,
with?
sorry, I didn't get your, could you repeat?
Sir, why don't you multiply all the values in bracket by 24?
uh, how would that work? Okay, I can, like, how would that work? If, see, this value currently, if you substitute the value of, if you substitute the value of x is equal to 2 directly here, so it would turn out to be 24 minus 24 divided by 0. That is 0 by 0, and it is not defined. We had learned that in previous class. You can't do it directly, right? So we need to factorize it. Yeah. Hello. Hello. Were you trying to speak something? Yes, factorize, exactly. You need to factorize, but how? So 2x square plus 5x minus 18. That can be written as, so one thing we are pretty sure about it. X minus 2 from the bottom has to get cancelled anyways. So one factor will be x minus 2. This is a trick for you for all the questions that we'll be discussing tomorrow also. And the questions in general of limit. So one limit has to be x minus 2. The other will be 2x. What will it be? What will it be? Tell me. It is 16, right? 36. So 36 can be written as 2x. It will be 2x. 2x minus 4. Are you sure? No, I don't think so. It will be 2x plus 9, I think. It will be 2x plus 9. Okay. Wait a second. It's minus 4x. Yes, yes, yes. It is. It is. You can try to multiply it also. Yes, it is 2x plus 9. So it will be 2x square plus 9x. Okay, 2x square plus 9x minus 4x minus 18. So it is turning out to be 2x square plus 5x minus 18. It is. It is. It is working correctly. It is working correctly. I guess there is some issue with this pen. Okay. So you substitute the limit over here. So it will be x minus 2 and 2x plus 9 divided by x minus 2. So as we had learned earlier, we are not talking about exact 2. We are talking about limit. So yes, it does get cancelled. We are only left with 2x plus 9 and its limit is tending to 2. So what will be the value? What will be the value? Yes, yes, 30. Not difficult. Okay. So this is what we call derivative. This is what we call derivative. Easy, easy. Yes, yes. यार, आवाज नहीं आ रही. Hello, you are not audible.
Sir,
Hello.
Iit is 13.
13, yes.
Why, sir? Why it is 13?
Uh, because see, we earlier had this value, okay? We earlier had this value. We evaluated this. When we came out, we factorized it like this. After factorizing, we learned that there was a factor of x minus 2 in both numerator and denominator. Since x was tending to 2, x was not equal to 2. I had mentioned it earlier also, x is not equal to 2. So x minus 2 is not equal to 0. X minus 2 is somewhere near 0. Okay, somewhere near 0. That means it is something like 0.0000001, something like this. But it is not 0. So since it is not 0, we can like we used to do x divided by x. Okay, like we have x divided by x. Similarly, we can do x minus 2 divided by x minus 2. Its value will be 1. So it got cancelled out. So after cancelling out, we got only 2x plus 9. That was the only factor we were left with. After getting 2x plus 9, we already knew that the value of x was 2. So we put it 2 here. So 2 into 2 plus 9. 9 plus 4, that is 30. Okay. So that means one thing that we have to infer from here. What do we have to infer from here? For example, you have this curve y is equal to 2x square plus 5x plus 6. You have this curve. At the point 2 comma 24, you are pulling a tangent. You can try it also. You can try it. You are putting this tangent at 2 comma 24. So the slope of the tangent or rather say the angle of this, the angle which it is making with the positive x-axis in counterclockwise direction, tan theta, its value would turn out to be 30. ठीक है, आ गया सबको समझ में?
Yes, sir.
ओके, आज आज में कुछ भी डाउट है तो अभी पूछ लो, एंड प्लीज मेक इट अ हैबिट to revise. Okay, I think we went a very slow today because I guess we were not revised. So it would be good if you do a revision every day that we learn. Okay, ठीक है. So तो जाने से पहले,
Give us some practice problems regarding to today's class.
sorry,
May you
could
please
you
give
repeat?
us some practice problems?
Yeah. That is exactly what I'm giving it. I will be meeting tomorrow and I'll be discussing the problem. I'll be expecting you to solve these problems. Okay. So first of all, we have y is equal to, okay, you only tell me any function. Any function you will tell that will be for today's problem. Okay. So yeah, who is there? Bhavna. Bhavna, tell me any function.
3x plus 7x, 3x square plus 7x,
Okay.
minus
Tell me
5,
one more. Tell me one more. Tell
4x
me one.
square
Okay.
plus 9,
4x square plus 9. Okay. Okay. And tell me the values of x also. Give me one value of x also.
Sir, why don't I give the value of y?
Okay, sure, you can do that also. But see, like for example, you have this problem 4x square plus 9. So you give me a value of y. Okay, for example, you gave me value of y, let us say 13 you gave me. So first, using that y, you will have to calculate x, and then imposing limit on it, you will have to find the tangent. So let's keep it fair now. Let's keep it easy. Otherwise, first you will have to evaluate x and then you will proceed further. So why can't we do it directly? Does anyone else have the... Okay. Anyways. Yeah, so tell me values of x.
Sir, 7, 9, 2.
7, 2. Okay. So I have one more problem, this problem, and x is equal to 3. Okay. So find the slope of tangents at these curves at the given values. At the given values of x. This is your homework for today. And in the last, I have a special problem. 3x cube plus. Okay. So not all pluses should be there. It would be easy for you. I will introduce a minus also. 8x square, then 7x, and x is equal to 1. Okay. So these are the problems you will have for tomorrow. Fine. These 4 problems you have to solve by tomorrow. Homework. Okay.
Okay, sir.
Okay.
Okay, sir.
Okay. Great. If you want, I can give you a look at how we did it. You can, I'm not sure. Actually, from tomorrow, I'll introduce that PDF maker also. So after the class ends, you can have the PDF. But today it is in the whiteboard, so you won't be having it today. But you can just have a look and you can take screenshot if you wish to. Okay. You can take the screenshot if you want.
Sir, may you please show the last question?
Yeah, sure. Last problem. Yeah, this was the last problem.
Yes, sir. Fourth one.
हो गया? ठीक है, चलो हो गया तो अच्छा है.
Sir, homework problem.
Sorry. Hello.
Homework problems. Fourth one.
Fourth one, this one? Sorry, I didn't get it. Could you repeat it? Hello?
Sir, from homework problems. Yeah, sir.
This? Okay, yeah. What is the, like, I didn't get your point. What were you trying to say?
I think she is
Sir,
writing,
I
sir.
didn't copy that.
Oh, okay,
sir.
okay. Yeah, yeah. Okay. Okay, you can write. Sure. So these are the four problems, okay? Please make it a habit to revise it. Otherwise, we'll be stuck on the same topic forever, okay? So make it a habit to revise everything you learned today. Okay. So if you guys have any doubt, we are here to. I am in today's topic. If you have any doubt, पूछ लो. नहीं है तो फिर good night. Okay, completed. Okay, great. Okay then. I am ending today's class over on my side. Okay, good night. Have a nice day.
Yes, sir. Thank you, sir. And students, tomorrow also same timings from 6:30 to 9. And you can do your homework, do all the homework that sir and ma'am has given you. And you can send photo to 73372852228. And please revise everything. Whatever topic has been discussed today in the classes, please revise it after. After the class, you can revise it again. And you can send your homework to 73372852228. We have kept phone number in the chat box. You can just see. Send your homework to 73372852228. Bye everyone. Again, we will meet tomorrow at 6:30 p.m.